Hello everyone, welcome back to the course Infrastructure Asset Management. My name is Chirag Kothari. I am Assistant Professor in the Department of Civil Engineering at IIT Kanpur. In this particular week, we started our discussion around framework for infrastructure asset management. Within that, we saw the generic infrastructure asset management process. We also discussed what is the role of data in infrastructure asset management. Then we briefly talked about data requirements, categories of data and the relevant types. In this lecture, the focus will be on prioritization of data. This lecture is the third lecture in this particular week. Let us revise what we discussed in the last lecture. We saw that as far as data is concerned, there are several types of data which needs to be collected, like the organizational focus, current condition, model assumptions, asset performance, total cost and so on. Now, the question is, can we collect all this data? This is a very cumbersome process. It will require a lot of resources. So, oftentimes there is a situation where we need to prioritize what information is important. The process of identifying what data is important and deciding how do we prioritize data is known as prioritization of data. That is the focus of this particular lecture. We understand that all the data which is required for infrastructure decision making cannot be collected. This is mainly because the collection process is cumbersome. Before we discuss prioritization, let us talk about what are the challenges in collecting projects data or infrastructure's data. The process of collecting data is highly cumbersome as well as resource intensive. The challenges include accessibility issues. Oftentimes, the data which is available is at multiple places. There are multiple stakeholders who are managing the infrastructure. They record their own data. Sometimes these systems don't interact with each other, and that is when it becomes tricky. We need to find a way to collect information from all the different data sources, and this leads to accessibility issue. Collecting data from all the varied sources makes it cost intensive. The next issue is data quality issues. When we collect data for infrastructures, often there are issues of quality of data. Sometimes we don't have mechanisms to ensure that the data is standardized. Sometimes multiple vendors are involved in collecting data and they use multiple equipments. These equipments are not calibrated, which again leads to quality issues. Doing data processing to ensure that we have a good data set is again cumbersome. Then there are resource constraints. We need a lot of resources. A lot of data collection is still manual or requires immediate manual interventions, which makes it resource heavy job. Next, there are issues of standardization. There are multiple agencies involved in data collection. They record data in their own formats. Sometimes these formats are not standardized, which leads to issue of standardization, again making it resource heavy for data processing. Also, there are multiple stakeholders and they have their own priorities. Everyone wants to collect data in their own formats. Oftentimes, the information which needs to be collected varies from one stakeholder to another. This is another point of contention. Also, the data which we collect for any public infrastructure has to be updated. We cannot use obsolete data. We need to update that data on a periodic manner. Thus, the issue of data management, ensuring that we have good data, is critical, but at the same time very cumbersome. Thus, we must prioritize what data we will collect. We should understand that collecting all the data is very difficult. Thus, we will have to prioritize. When I say prioritize, we will have to select that okay, out of these 10 data sets, 6 are essential. I will only collect 6 of these. We acknowledge that having all the data is always beneficial, but it comes at its own cost. Thus, we try to prioritize what data is really important and we only try to collect that. With that introduction, let us dive deeper into the aspect of prioritization of data. Prioritization basically is a process of identifying what data is important, at the same time understanding what data should we collect and how often do we collect it. So, we are trying to address two questions: what data to collect. So, this will have a list of all the information that is required for decision making, and how often should we collect it. As we discussed that every data we collect must be updated regularly. Now, the question is, how often should we update it? Prioritization of data will include these two aspects: one around what data to collect, and second around how often should we collect and update it. I think all of us will agree that cost of collecting each and every data is too high. We need to understand some of the potential attributes which could help us in taking this decision for prioritization. These attributes include the level of decision making. The level of decision making governs what data should be collected. The relative importance of the data, how important a given data is for decision making. The variation in the measure, the resources required, and the cost benefit of the data we collect. And finally, the frequency of use of that particular data set in the decision making. There are other criteria as well, but in this particular lecture, as far as infrastructure decision making is concerned, we will limit our discussion to 5 of these. Now, let us discuss how do we go about prioritizing. There are several methods for data prioritization in the field of data analytics or data science. The idea in this lecture is not to go into details of each of these. Here, we will look into a more philosophical discussion around how should we go about prioritizing data for infrastructure projects. Let us discuss the first aspect, which is around level of decision making. For any infrastructure, there are multiple levels of decision making. We understand that the data collection which we do should align with the decision making level. The levels include strategic level, network or program level, and project level. At the project level, the focus is on decision making for a given project. So, this could include a specific building or a specific road, a specific bridge or a specific airport. The decision makers who are required to do decision making at the project level will focus more on asset specific data. Here, they want to collect all the relevant information about the asset under consideration, and they will use this data to evaluate what are the potential treatment alternatives, what are the possible maintenance and rehabilitation techniques that can be used. This is at the project level. Now, at the network level, there is a collection of multiple projects. We have multiple projects which are there as a part of a network. Oftentimes, a set of projects are known as programs. Now, the decision makers who are doing decision making at the program level will need to understand that what are the network characteristics. They would like to do some trend analysis. They would like to also understand different aspects of risk as well as life cycle costing. So, at the program level, instead of focusing on a single project, the idea is to look into multiple projects together. We try to assess multiple projects to understand different trends. Also, we try to understand the risk profile of projects in a given region, and we also look into things holistically to understand the life cycle costs. At the network level, we sometimes need data to select relevant projects. The idea is that at the network level, we are in the process of selecting relevant projects. The projects which are selected at the network level, we go about collecting the relevant data for them to decide a M&R technique which will be used. M&R stands for maintenance and rehabilitation. So, the idea is that at the project level, we should collect asset specific data, but at the same time, there should be a mechanism to aggregate data which is collected at the project level so that it can be used for trend analysis at the program level. So, it is important that we prioritize data which can be used both for project level decision making, but also it can help in program level decision making later on. Now, if we move above network there is another level of decision making which is more strategic. Here we are looking at things more holistically. So again, the focus at this particular level is on high level metrics. Instead of collecting very asset specific information or very minute information about a project, in case of strategic decision making, the focus is on a high level metrics. Here we want to use some aggregated data so that we have some metrics which can be a representative of the assets we have. Here again, the focus is that whatever data we have as part of the project level decision making as well as network level decision making should be in such a manner that it can be aggregated so that it can be used for strategic level decision making. Let us see this with the help of an example. Say there is an agency which is looking after all the projects in India. Let us assume a highway road agency which is required to manage all the highway assets in India. So at the strategic level, they will focus on a high level metric. They don't want information about each and every project. They would like to see what is the overall performance. They would like to understand that maybe 70% of our projects are in good condition, 20% need repair, and remaining 10% need to be reconstructed. So they are interested in a high level information. However, they cannot go and collect information on their own. They will have to rely on project level information and network level information which is available. Now, say once they have this information at the strategic level, we move to the next level which is around a network or a program. Say instead of national level, now we have a state agency which is responsible for all the roads in a given state. Now, this agency would be interested in understanding different aspects. They would want to do trend analysis, see how cost is varying from one project to another within the state. They would also like to see what is the life cycle cost and if there are any maintenance or treatment techniques which are better suited for their state. So at the program level, they will do decision making which helps the state. They will do this with the help of data which is collected at the project level as well as at the network level. Finally, at the project level, we do a more concrete decision making. At the program level, we decide the list of projects. So we know all the projects which require repair. Now, at the project level, the decision maker will collect all the relevant information for that particular project, and he or she will try to assess which maintenance technique or which rehabilitation technique is best suited. So the whole idea here is that data prioritization should emphasize on what is the purpose of collecting the data. How do you want to use this data? Also, you need to consider that is there anyone else at higher levels who might need this data? If so, we should encourage standardization as well as create a mechanism so that the data can be shared with people at higher level. The whole principle here is we want to avoid duplication of data. We don't want a situation where the project level team has already collected a lot of data, but it cannot be used at the national level. The national level agency needs to go again and collect the same data. So we have discussed that the data we collect should align with the level of decision making. Now let us discuss the next consideration. The next consideration is around the data we collect should align with the relative importance of that data. This is another very important aspect. You only want to collect data which is relevant and important. So for any infrastructure, we'll always have data which is of low importance, medium importance or high importance. But it is easier said than done. How do you really decide which data is important? What is more relevant? Now, one way to think about this problem is to answer this particular question. You try to ask yourself if there is a high likelihood that the information we collect will change our decision, then this is an important data. However, if we have a data which will not change our decision. No matter how important it is, if it is not changing our decision, then it is not relevant to us. Because the idea is we want to decide which maintenance technique should we adopt. If I have 5 options, maintenance 1, maintenance 2, so on till maintenance 5, I only want to collect relevant data which helps us in understanding which maintenance technique should I adopt. If the data I collect is not helping us in taking this decision, then it is of low importance. Additionally, we also need to understand that do we have this information available in some another form. So, if the answer to the first question is yes, that is the likelihood of a particular infrastructure data set impacting our decision is high, then we should also ask ourselves that do we already have this data. It is possible that this data is available to us in some other form. If that is the case, you do not want to waste money in collecting this data again. So, the idea is that you want to ensure you only collect data which is relevant or important, and also you try to collect data which is unique. If there is any overlap in terms of data we are planning to collect, then we can prioritize and only collect the data which is a good representative of other data sets. Now, let us discuss how do we go about making this decision. In order to align data collection with relative importance of data in the decision making, first let us discuss a basic decision making framework. For any infrastructure decision, we generally start with values or goals. We try to list out what do we want to achieve from our decision. Then we try to take some decision which aligns with what we want to achieve. This is important that we have a clear understanding of what we want, and then we take decision which aligns with what we really want. However, for any infrastructure project, we acknowledge that there are uncertainties. There are some things which is beyond our control, or there are some aspects which are not available to us right now, and this still may impact what value we achieve from the infrastructure decision we take. So, if I break it down for a civil infrastructure, the decision is around what projects to undertake, which projects should be maintained first, what maintenance technique should I employ. So, project selection and then the type of maintenance is part of the decision making. Now, this decision making is governed by what you want to achieve. Our goals could be around economics, we could have economic goals, we can have safety goals, we can have environmental goals, equity goals, resilience goals, and so on. We can have multiple goals. So, we want to take a decision which aligns with our priorities. Next, we understand there can be some uncertainties like financial uncertainty, there could be uncertainty around the effectiveness of treatment, there could be an uncertainty around the demand for the infrastructure. It is possible that an infrastructure currently has low demand, but suddenly there are some changes in the region and demand for that infrastructure has increased considerably. Also, there are issues around climate change and so on. So, what we try to achieve here is that we will only collect all the relevant information which helps us in this particular decision making. So, if I look here, we want to collect information around what are the projects which I can undertake, what are the maintenance techniques available, how these maintenance techniques align with the values which I want, and if there are any uncertainties, how can I collect relevant data to understand these. This is one part of the problem, that is you want to collect information which is important. Second is we wanted to collect information which is unique. One way to test for uniqueness is using a correlation matrix. So, for this particular decision making framework, we are trying to assess whether the data or information which is collected will change my decision. If the answer to this particular question is no, then we need not collect this particular data. If the answer to this particular question is yes, then it is worthwhile collecting this data. At the same time, we need to ensure that the data which we are collecting should not be available with us already. That is where the concept of correlation comes into picture. So, here we are trying to understand whether the information which we feel is important, does it correlate with other information which we already have, or does the information we want to collect is already part of some other information which we are planning to collect. If that is the case, then we can prioritize and only collect one type of data. Let us see what is a correlation matrix. A correlation matrix is a statistical overview of how different factors are related to one another. The idea here is, say there is a data information, data 1, and there is another set of information which is data 2. If data 1 and data 2 are correlated, basically what we are saying is that if there is some change in data 1, a similar change can be seen in data 2 as well. And if that is the case, why do you want to collect both the data? You could just collect one of the data because the information about the other set of data can already be estimated with the help of data we have. Let us see this with the help of a practical example. A correlation matrix looks something like this, where on the x-axis as well as the y-axis, you have the different options for collecting data. For example, condition index, this is typically a numeric number which gives us an idea of what is the condition of an infrastructure. Generally, we say that 100 means excellent conditions and 0 means poor conditions. So, the condition index for different infrastructure needs to be estimated. Now, say there is another information which is around traffic volume. Then we have maintenance costs, and finally we have the level of risk for a given infrastructure. If you see here, the same 4 parameters are written on the y-axis: risk level, maintenance cost, traffic volume, and condition index. Now, each of these cells are giving us an information about how are these 2 parameters correlated. So, for example, if I focus on condition index here and condition index here, this is the matrix which gives us an information. Obviously, both these are same parameters. So, they are highly correlated, which is given by a correlation number of 1. A positive correlation here means that if one variable is increasing, we are seeing that the other variable also tends to increase. Now, a correlation of 1 means these 2 variables are perfectly correlated. So, the entire diagonal here, if you see the diagonal here, will have all the correlation numbers as 1, because each of these diagonal elements represent the same element. So, traffic volume here is correlated with traffic volume with a correlation index of 1. 1 means 100% positive correlation. So, diagonal of any correlation matrix is typically 1. Now, let us have a look at some of the other numbers. Let us see how condition index is linked with risk. So, you see here that there is a negative correlation, which means that if one variable increases, the other tends to decrease. So, if the condition index is high, we are saying that the infrastructure is in excellent condition. In such a case, obviously the level of risk will be low. So, this information is communicated with the help of a negative correlation number. A number closer to -1 would mean higher correlation, but in the negative direction. So, a correlation matrix, if it is closer to +1 or -1, would mean that the variables under consideration are correlated. However, if there is a correlation which is close to 0 or say something like 0.3, then we are saying that these 2 variables are not correlated with each other. So, I hope the idea of correlation matrix is clear. If you have any questions around what is correlation, I would encourage all of you to look into some of the books around statistics. You will have a clear understanding of what is correlation and what is a correlation matrix. In this particular course, we will look into how to use correlation for prioritizing data sets. For example, if you see here, risk level which is mentioned here is negatively correlated with condition index, but there is a very high correlation. Similarly, traffic volume is also related and maintenance cost is also related. So, one could argue that if level of risk is one of the important criteria for decision making, then it is worthwhile to collect information around condition index, about traffic volume as well as maintenance cost. At the same time, if you look at this correlation matrix carefully, you see that traffic volume and maintenance cost are also related to each other and there is a high correlation. Now, one could argue, why should we collect both the information? Because it seems that higher the traffic volume, higher is the maintenance cost. So, there is a possibility that they might be correlated. So, a correlation matrix can be used for this purpose. The idea will be clear with another example. Let us consider there are 5 types of data which can be collected, but we do not have enough money to collect all the information and thus we want to prioritize data collection. Say the 5 variables we have are for a road infrastructure and we have information such as traffic volume, the toll collected, condition of the road, cost of maintenance and age. Now, we here use the past data. So, if we have data for past projects around all these 5 things, we can use that data to prepare a correlation matrix like this. In this matrix, we will look for all the values which are closer to -1 or +1. So, one could argue that data collected is very closely linked with traffic volume. So, as part of decision making, we could say that we will only collect one of these information. As long as we have a mechanism to account for the volume of traffic flowing on a road, we do not need to collect information about how much toll is collected, because these two things are connected. If the amount of revenue collected is already available, then we do not need to estimate traffic volume separately, because these two variables are correlated. Similarly, if you see here, condition of road and the cost of maintenance is again negatively correlated. If the condition of the road is high, then the cost of maintenance is low. Again, this is very intuitive. So, one could say that we can just use condition of the road to predict what will be the cost of maintenance. We do not need to collect this information again and again. As long as we have information of what is the condition of road, we could use that to estimate the cost of maintenance. And we can also see that age is an important parameter, but is not correlated directly. The data shows that there is low correlation with all the other 4 variables. So, for this particular case, one could say that I will only collect 3 types of information. I will collect traffic volume, I will collect condition of road and I will collect age. I do not need to collect information about the tolls collected and the cost of maintenance. These two can be determined using the data which we already have. Conversely, you could say that I already have information about the tolls collected. In that case, I will just use this information and I do not need to estimate traffic volume separately, because these two are correlated and thus I do not really need to collect this information again. So, I hope the idea of correlation matrix is clear. Please note that the correlation matrix can only be used if the relevant data is available. So, as part of decision making, we are basically analyzing all the past data about a given type of infrastructure and then we are seeing whether these data sets are correlated. And if they are correlated, then in the future we can avoid collecting all the data. We can only collect some of the important data sets which are a good representative of the overall infrastructure data set. I hope this concept is clear. Now, let us move on and discuss some of the other aspects which should be considered as part of data prioritization. Next, we have something known as variation in the measure. So, we saw that we need to account for level of decision making. We also saw that we should only collect data which is important, and we should also collect data which is unique. Now, I am saying we should only collect data which has high variation. Let us see what does this mean. Variation in the measure. Here we are doing a range analysis. Range generally means the maximum value minus the minimum value for a given data. Obviously, this value could be high, low or medium. Now, if you have a parameter where variation is very low, then you could say that this particular parameter has low variation and thus it is not so significant. Maybe it is not really worth collecting data around it. At the same time, if there is a parameter which has very high variation, then you may indicate that there is a higher significance as far as decision making is concerned. So, the goal here is that you want to choose a data set which has higher variation, because all the data sets or all the parameters which will have higher variation are more likely to provide more value in decision making. Let us look at this from an example. Say we want to take a decision on should we maintain a road section between two data points. Say there is a data point A and data point B, and we want to decide whether any maintenance or rehabilitation should be done on this particular data set. Suppose there is a list of different criterias, for example, traffic, initial condition of the roads and weather. Now, when you go about collecting data for this particular road section, you get an information that the variability in weather is very low. There is a region where temperature is not changing a lot. However, the variation in traffic is very high. You see that on some days traffic is very high. There are some seasons again where traffic is high, and so on. You also see that the initial condition is varying. So, there is a medium variation. Now, basically what I am trying to communicate here is that if there is a parameter like weather which has low variability in a region, then potentially there is less value which you will get by collecting information about weather, because since there is low variation, it will not have any significant impact on decision making. You can actually prioritize the other two data sets which have medium or higher variability. I hope this concept is clear. Here we have seen variation in a given parameter. That is, we are seeing what is the variability in the data which is collected. But in addition to this, we also need to understand what is the variation in a given data set over time, because once we have that information, it could be used for deciding the frequency of data collection. So, here we are looking into what is the variation in the measure over time. If there is low variation, it means that this particular variable is not changing with time. Then probably the frequency of collecting that information can be low. You can collect it once and later you do not need to collect it again and again. However, if a particular variable is changing a lot with time, then we need to collect this information more frequently. So, when we are looking into variation in a measure, we are looking into two aspects. One is how much variation is there within the parameter, and then we are also looking into how much this particular parameter is changing with time. So, now there could be a case where we might see that the parameter we have or the data we have has high variation, but it does not change over time. So then what we are saying is that a data set like this is worth collecting once because there is enough variation in the data set. However, it doesn't change much over time, so we don't need to collect it again and again. There could be another possibility where there is low variation in the data set right now. So when I am seeing this particular data set right now, there is low variation in this measure. However, with time it changes a lot, high change over time. So now in such a case, we would like to collect this information. For example, say you are in a particular colony or a residential township where you have recently maintained all the road sections in that particular residential township. Now obviously, when you try to assess the variation in the condition of the road, since all of them are maintained recently, you will see that there is very low variation because most of these road sections will have a very high condition, say around 90 to 100. So the variation is low. However, you acknowledge that with time there are some road sections which will see more deterioration than other, and thus the variation over time is higher. So now in such a case, what we are saying is that information about road condition right now shows low variability, so it is not important for the decision making. However, since it is changing quickly over time, it is important to record this information over time to make an informed decision about maintenance and rehabilitation. So I hope the idea is clear that the data which we are collecting can have high variation, but it doesn't change over time, or the vice versa. Now we have discussed three aspects. Let us move on to the fourth aspect. Till now we have identified what data is important based on different metrics. Now another important consideration is how much money will we need to collect this information. The money required to collect information is one of the most critical criteria. We might see a situation where we understand that collecting information is very useful. However, it is coming up at a very high cost. Then the question is, how do you prioritize? The information about resources required or the money spent on collecting data is important. We need to ensure that we collect all the data at a low cost, because we have already seen that data collection is costly. So we want to prioritize data which can be collected at a lower cost but has higher benefits. Let us discuss this in detail. So for any information or data which you classify as important, you need to ask two questions. For this particular important data set, what is the cost of collecting the data? How much resources are required to collect this data? And next, you want to know what is the benefit achieved by collecting this information. And then there is a parameter known as benefit cost ratio, where you try to quantify a monetary value of all the benefits and divide it by the cost of collecting the data. And we say that a benefit cost ratio greater than 1 would mean that there is more benefit in collecting an information than the cost of collecting it. This becomes an important criteria in decision making. If something is costing you more than the value it provides, then it is not worth collecting that information. So you want to only collect data which has a benefit cost ratio greater than 1. Now if there are multiple data points where you have a benefit cost ratio greater than 1, then you basically try to prioritize all the data points which have a higher benefit to cost ratio. So the idea is that if something can be purchased at a low price and has high benefits, then the benefit cost ratio will be higher, and this is useful for us. So benefit cost ratio can be used to understand whether it is worth collecting this particular information. Here, the difficult part is how do you quantify benefit of a given information. So again, you are trying to understand whether the data which I am collecting, is it impacting my decision and by how much. If the answer to this question is yes and very much, then you are saying that the benefit of collecting this information is very high. Now, moving on, the last aspect which we should consider in data prioritization is around frequency of use. That is, the information we collect, how often we will use it. Again, any information which will be used again and again for multiple decision makings should be prioritized. Basically, what we are saying is that at the level of decision making, we saw that there are 3 levels: strategic decision making, network decision making, and project decision making. Say there is a data which can be used at all the 3 levels, then obviously it has to have higher priority because it can be used by multiple stakeholders at multiple levels. However, say there is a parameter which is only used at the project level. On the other hand, sometimes we might have a parameter which is only used once. So then this particular parameter will have a lower priority compared to some of the other parameters. So these are just some of the potential attributes which should be kept in mind when we go about prioritizing data. We need to understand what is the purpose of collecting this information, what is the relative importance of that data, how much is this data varying, how is it varying over time, how much resources will be required to collect this data, what is the benefit of collecting this information, and finally, how often will we use this data. All these are important considerations in the decision making. Having discussed some of the considerations, the more important question is, okay, we understand what all we should consider, but how do we take this decision? How do we implement this in real world? So let us briefly discuss what are some of the different methods for prioritization. Till now, we have discussed different considerations which are kept in mind to prioritize data. Now, I'll just walk you through some of the methods which are available for prioritization. This course is focused on giving an overview of the different aspects which are part of infrastructure asset management. All these methods will not be discussed in detail as part of this course. However, we'll discuss 1 or 2 of them in the subsequent lectures. Different methods for prioritization of data. Some potential methods include weighted scoring methods. This is a very common method which is used by decision makers, where they first identify different criteria. So say to take a decision, there are 4 criteria. For example, say you want to purchase a car. You might say that the 4 criteria I have is, it should have higher mileage, it should look good, it should be safe to ride, and it should be from a branded company. Now, once you have these 4 criteria, you go about assigning weights to them. So you say things like, okay, out of 100, safety is the most important thing for me. Then comes looks. I really want a good looking car. You might say mileage or the average the car gives is not of importance to me. So you assign different weights to each of these criteria. Next, for each alternative you have, so you have an alternative of say car 1, car 2 and car 3. For each of this car, you try to understand how would you rate it on mileage, do you like the looks, is it safe according to you, and so on. You give some score to each car and then you multiply this score by the weights to calculate overall importance. So the idea is that a complex decision making includes multiple criteria. A given alternative will perform differently on each criteria. So we need to assign weights to each of these first, and then based on the scores assigned to each alternative, we multiply that by the weight assigned to each criteria to get overall importance. For the time being, you can just understand that the idea is to assign weights to different criteria and then finally take a decision. For students who are interested in knowing more, we will put some references which can be used to understand this aspect. Now, let us see another method. It is known as AHP. It is again a multi-criteria decision making method which is used to do pairwise comparison to understand relative importance. Here, the idea is that as a decision maker, it is difficult to assign weights to each criteria. For example, when I asked you how much weightage would you give to safety over looks over mileage, and I asked you for a fixed percentage, it is really difficult to say whether you give 50% weightage or 30% weightage. To overcome this, what is being done is there is a method known as AHP where they do pairwise comparison. So they will ask you that just compare safety versus looks. What is more important? How important is safety over looks? And then you are generally asked to give a number between 1 to 9. And based on that, these weights are finally determined. We'll discuss AHP method in one of the subsequent lectures. Now, in addition to weight scoring methods in AHP, another method which is available is known as Eisenhower matrix. Here, you try to plot the data in the form of a matrix, where you say urgency is on one axis and importance is on another axis. So now, any data point which is important at the same time urgent, really required at the moment, will be there in quadrant 1. So what you are trying to say is that all the data which is urgent, required immediately and also important will be given first priority. This is another way of looking into prioritization. Sometimes it is very helpful to think of any problem like this because it is very intuitive and easy to use. You are just trying to understand whether something which you are collecting is important and is it urgent, do you really need it now or can you wait for some time. Next method which could be used is a principle known as Pareto principle, which says that 80% of the results come from 20% of the effort. This is generally applicable to a lot of other things. There are several examples of a Pareto principle. In case of infrastructure decision making, we are hypothesizing that we are trying to identify 20% information which will contribute to 80% of the decision making. Not all the information we collect has an equal role in decision making. So you want to only prioritize the top 20% of the information which will 80% impact your decision. You say that having collected this information is good enough because I understand that 20% of the data I collect will basically contribute to 80% of the result. The remaining data is not really helpful at this stage. So these are some of the potential methods which could be used for prioritizing data. With that, I end our discussion here. In this particular lecture, we have seen what is the need for data prioritization. I started discussing some of the challenges in data collection, and then we acknowledged that data collection is cumbersome and costly. Thus, we need to prioritize what data we will collect. Then we discussed different considerations. I talked about 5 of them here. We saw how these considerations play a role in the decision making with the help of a decision making diagram. We also discussed how to use correlation metrics for this purpose. Finally, at last, I discussed some of the potential methods for prioritizing data requirements. I hope all of us have an understanding that we need to prioritize data collection. It is important that we acknowledge collecting all the information is costly, and oftentimes it is okay to only collect the relevant information which will help us in majority of the situations. Now, Here are some of the important references around this topic. With that, I'll end our discussion here. Thank you. Thanks for listening.